Hello, everyone. Welcome to the second week of our internship for machine learning. Thank you for joining us. Let me just quickly share my screen and we can start right away. Okay, before we start, we have these two numbers. We are repeating them all the time. So remember them, 24 and 74. A simple hand rule picked the right pages 24% of the time, and a real model was around 3 times better. And I left you with one question: why the model won? And today you will get that answer. So we already discussed this topic last week, but just to make sure, we don't need ML every single time. We are using machine learning only when it has its place, and only when it's relevant, and only when we need it. For example, if we are in the present time and we already have all the data and we just need to check right away, we don't need ML for that. Interpretation can be done immediately without any prediction. Sometimes a rule is the best tool, and sometimes a dashboard is enough. And sometimes only a model can do the job. The real skill is to know which one is which, and this is today's lesson. So by the end of this video, your search questions will become real machine learning tasks. So you will know exactly the task type, the thing you predict, and you will establish the scores we need to judge it. So we will always know, are we doing our job correctly? And the second half is hands-on. Real data, real conversations with AI, step by step. In the last week, we predefined the problem we currently have. The problem comes from the SEO nature. We have content that ranks, and then it quietly decays and starting going down. It drops. We had two notebooks inside of our GitHub, and you run both of them. That was your first assignment. And that was the way to check how it looks like and what we are expecting from you. Now we are picking our lanes in this second week. We have predefined capstones inside of your track, as I already mentioned, and your goal is to find the lane that fits you the best. So my personal favorite is freestyle. You have so much flexibility there and so many opportunities to challenge yourself. But lane is just a strong choice. Both are completely and totally fine. And one more thing, we had some kickoff questions last week and we answered them inside of our portal. So check the post called How the Assignments Work. So read it once, save it. So just make sure to check it out. We have so many repeating questions. We should be good now with these. Okay, right from the beginning, same as the first week, learn the idea first and use AI second. So first we need to define what we are solving. And only after that, we are coming to the tool that will be used in order to solve it. In this presentation, I will cover the exact actions that we need to use in order to solve our problems and to use ML correctly. We hear this a lot of times. Everybody calls AI everything that is related to the LLMs, large language models. And that is partially true. But here is the deal. We have some differences here. And so let me give you the map. Artificial intelligence can be anything that acts smart. It doesn't have to be an LLM or machine learning technique. Even a system with handwritten rules can be AI. Below that, we have machine learning. So what is that? That is a program that learns the patterns from the examples. We are analyzing previous behavior and historic data in order to predict stuff. And why we are doing that? We want to set up something in the present and to expect the best behavior in the future. And LLMs like ChatGPT, Gemini, or Claude, they are the smallest circle of all. And one important thing there, when you prompt ChatGPT, you are using a model that somebody else already trained. So you are only using it and we are creating our own model on our own search data. Okay, which questions are you asking? If we need some stuff right now, and we are not trying to predict, we just want to know exactly how our stats are looking at the moment. For example, in that case, we obviously need the dashboard. Or if we already know the logic, we just write the rule, and based on that, we know exactly how it looks like. But if we need to predict how it should or could look like, we need machine learning. So do this now. Take your lane question and put it into one of these three rows. Your notebook this week asks you to defend this exact choice. So you will check it after this video, or assignments are already there. Now, one true story from FlyRank. Our platform mark content with flags, and every single flag is handwritten rule. For example, we have a flag called needs CTR fix. So let me explain SEO terms first. CTR is click-through rate. It is a basic metric that calculates how many people saw your post and how many clicked. Higher the number, it's better for us. Impressions are basically visibility on Google search. So Google provides us exposure, and eyeballs already so many eyeballs already see our post. But if we have a problem, if nobody is clicking, inside of Google, you have a snippet for each search result. As you already know, we have title, description, and possibly image. And that is the only thing that users see. So if Google decided our content is valuable and we get tons of impressions, but nobody is clicking, we need to fix these titles, descriptions, and images first. And we need to know which pages are performing the best and find the pattern between them. The rule catches the problem, but the pattern behind it, this is the part we actually need ML. So same stuff here. If we want to determine, is it cold right now, we need just the logic and a rule. Let me explain it in simple terms. If we have 20 Celsius degrees and we say, hey, it's cold if it's below 20, it's hot if it's above 20, we already established the rule here. The rule is a threshold on 20 degrees. Pretty much that's it. But if we want to know the weather next week or next month, we need to know our historic data, how it looks like. We need to predict that. We need to see the seasons and all the factors behind it. So no single rule can hold that. And one thing that is coming in week 4, Haris Hodzic opens the hood on our real flags. So productional data, and just be there. And you will build your own rule with him. The rule that your model must beat in week 5. So we already touched on this point so many times. In most cases, the board is creating some type of data, and we are trying to use that data to interpret it and analyze it and make some model in order to predict. After the prediction, we'll have some actionable steps so we can utilize the data in the best way possible. And with that action, we can potentially impact the world itself. And we are going back in the loop at every point. And at every point of the time, we should always have these two questions. What we are solving and what good or bad looks like. So we always need to know the direction where we are going. If we want to determine how to write the best article or what is the best keyword to start our process, we always have these two in our mind. And we are not able to fix and track multiple steps at a time. We have a focus only on one thing at a time, one problem at a time, and pretty much that's it. So these two questions come back again in the end of this video. And we have two types of machine learning. And I'll try to explain the two different types that you will utilize in your own lanes. Keep just the second. Okay, so we have supervised and unsupervised. Supervised basically means every single example already has the answers, and the model learns to give that answer for new examples. So we already know how our outcome should or could look like. In unsupervised, no answers exists. The model finds groups of similar things on its own. And now look at your lanes. We have refresh scoring, ranking signals, CTR opportunities, and those are supervised. Each row can carry an answer. Archetype clustering, that is unsupervised. So your lane choice already decided which family you are in. You just didn't have the words for it yet. Now you have it, right? Okay, we have two charts here. One is for supervised and the another one is unsupervised. And see it clear, both pictures are drawn examples. They show the shape of the results, not our numbers. In the first one, we have some pages. Every single row is one page. And we have the click strand flagged on every single row, falling or rising. And that field answer column is exactly what supervisions means. When we get the new page, we want to flag it immediately. And how we are flagging it? With the ML model itself, right? We already have this historic data. We did the analysis and the model gives the answers for the new page. Of course, in SEO, we should always give some time to the content. Only after a few months, we know the real trend. On the right side, we have unsupervised. We have different types of keywords here. On x-axis, we have traffic, the counts of visits, and on y-axis, we have conversions. And the model grouped the keywords into navigational, commercial, and informational. It did not tell us what they mean, but a person reads the picture. And as we can see here, the highest conversions we have on the informational keyword type. So when we filter which keywords to start with, we choose informational, right? So just for context, keywords are always starting point for every content piece in SEO. It is basically the Google search query we are writing, and we are writing our content around it. And in the best case scenario, we will chain the analysis together. If the click trend flag is already there, that means one ML analysis was already done before this one. And that is the one of the better utilizations of ML. And we will do it all the time. And do this now. Figure out which lane you want to pick and say it loud. My lane is supervised because, or is unsupervised because. That sentence goes into section 1 of this week's notebook. And I know this. I know I owe you something from the last week. And last week I planted a warning and promised we will deal with this in the following week. So here it is. We could have overfitting issues, and overfitting basically means the model memorizes the examples instead of learning the pattern. We had this example last week. So imagine a student who prepares for an exam by memorizing last year's answers. Every question from the last year, perfect score instantly. But next year, we have a totally different exam. And now we have so many wrong answers. And model can do exactly that. Instead of learning the general pattern in your data, it memorizes the specific examples you trained it on. It scores nearly perfect on the data it has already seen. And after we put it in production, with the real data it has never seen, it fails completely. So it can happen if our data set is potentially too small. We will touch on this part many times in the future. Here I have one conversation with AI. So we have a chat there, and we are asking him, hey, can you explain overfitting to me like I'm a junior? And this is probably one of the simplest and cheapest tricks out there. So just say, explain to me in plain words like to a junior or a kid. In many cases, the answer will introduce new terms. And what we are doing in that situation, we are doing a follow-up prompt. So in this example, we got a new term, depth. So we ask, You say too much depth. Is that the number of features we use? And we get the answer that it's not correct. Completely wrong. Our assumption is not correct. Features are the menu of columns. And depth is how many questions in a row the tree may ask. And now, since we already connected our Hugging Face dataset with our agent, we can freely ask him what value for depth we need to use for our case. And as you can see right there, we already got the answer and the instruction. Use max depth 4, and if the target of the features change, run the test again. So you will do this every single time. You will ask him to explain the stuff for you and potentially even do stuff for you. And you will validate it with another model and with your own context and knowledge. You need to be aware of the concepts and the rules we have in machine learning, and I will keep repeating that many, many times. So, generalization. Our final goal with ML is generalization. And that means we want our model to do well on the data it has never seen before. So we don't want overfitting. We want high scores on the new data. Training will occur, for example, on 80% of the data, and we are validating on the another 20%. For us, it means even more than that, since we have larger data sets and larger historic data. So the easiest example, if we have 12 months of historic data, we will train maybe on 10 months and validate it how it works on another 2 months. And keep this in mind. The goal is not zero memorizing. So memorizing is totally fine. But the goal is the score on the new data. Now we have so many new questions to answer now. We are coming to purpose and problem framing. And this is the section 3 from our core framework file. So we have this file somewhere inside of your repository. Maybe some of you are aware of that, but I will mention this file again in this presentation. So we are introduced to new questions. What problems are we solving? What is the cost of wrong decision? What does good mean before we choose a model? You will get these questions all the time. Since you are new in this field, you will always be in need to search for an answer, for a new term or a new technique. And I'll show you one trick at the very end of this presentation that will solve 90% of these doubts. So keep watching. So every single time we will have this framing flow. We need to define the goal and decision to improve. After that, we know exactly which ML task type this is, what is our target, the metric, the model output we expect, and exactly what to do after we validate the results, and obviously action. So let me run it once on our refresh lane. So we have a goal, and our goal is earn more from the content we already have. We have decision. So FlyRank already watches thousands of pages automatically, and that part scales. But let's imagine the shipping refresh does not. Somebody reviews and proves it and publishes it. So if we, for example, ship around 50 refreshes a month, and by the way, refresh is actually rewriting the content, rewriting it from scratch or just modifying some sections. Pretty much that's it. Same content, but updated. So our team can ship only 50 refreshes a month. And decision is which pages get one of these 50 slots. We have task type. It sounds like classification, declining yes or no. But we need an order for these slots. So we frame it as a scoring. We have data. One row is what? And in our case, one row is one page. So we have 30,000 rows since we are using this sample data set from CSV, for example. The target, we have label is declining and around 54% of the pages. What we really want is worth a refresh slot, but we cannot measure that. So we predict stand-in that we can measure, and we name it out loud a proxy. And you will search for this term, what is proxy, inside of our MD that I will mention again at the very end of this presentation. So the metric is precision at 50. Of the 50 slots, how many went to pages that really needs them? The handwritten rules fell of 50, around 24%, and the model was around 3 times better. And that is what 24 and 74 means. The model output rescore for every page sorted in a ranked queue. And we have action. We have to ship the 50 refreshes. And keep it in mind, the core principle, word for word, choosing the objective is not training detail. It defines what good means. A technically strong model can still be useless if the objective does not match the real decision. And do this now. Write 2 sentences for your lane. Which pages should we update or something else? And one row equals one what? In our case, it's obviously one row is a one page, since we are providing you pages data sets, but you will need that all the time in your future work. They are sections 1 and 4 of this week's notebook. Okay. Okay, now AI. Now we need to know how to use AI in this stuff. And I'll teach you a few of these tricks we use all the time. And I'm sure you already use some of them, maybe all of them. So move 1. Make it question. I ask you questions. You ask ChatGPT, Gemini, or Cloud to ask you the questions. And this way you will find the gaps you totally missed and all the stuff you actually forgot to ask. This is the cheapest way to fill these gaps. And we have these README and skills MD files in your repository, and you will always reference them and ask the agent to utilize them. Before the initial implementations, always ask it, hey, can you interview me if you have any knowledge gaps, if you need some more context or anything else. And that way you will form a clear picture for your LLM and for yourself as well. Move to the discussion. This is a basic conversation, just like you will have with anybody else. And you are framing your words, and you will always ask him to be as objective as possible. Move 3. Make it defend and then judge. Ask what target it would pick, check it against the data dictionary, and you will decide what's wise. Move 4. Get a second opinion. And that is really, really critical one. After you have some conversations with particular LLM, you will have some decisions, some wider picture, and some context behind your analysis. Before the initial start, you will always ask for a second opinion. It could be even the same model, but you need to open a new clean conversation without the context of the previous one. Or even use another model that is even better. And that way you are checking the stuff from different directions and different angles. Whether you do with AI, always ask for a second or third opinion. And that must be a rule there, 100%. And the thinking, you will do that part. You are not outsourcing it. You can always borrow the ideas and find some inspiration from the AI, but you are the one who makes decisions there and this thinking part. Here is one more advice. We already connected our local repository with our Hugging Face datasets. And that means your agent already has access to these datasets. You can ask any single question you want about it. And that will provide us so much more context, and to you and to your agent as well. It will make it easier for him to pick the best analysis and the best techniques for the particular case. And yeah, we have same stuff here. We will ask him what data we have there. So can you explain this table, this column, and what can I do with this data? And this way, while we are getting the context, the agent will immediately get the context too. And that is very, very critical part. And one more thing, we intentionally put some stuff in your data sets as well. So you will never ever have clear data if you do ML stuff. You will never have everything perfect. So we have some gaps, some missing data, and some flags that you maybe never know they existed. And in this example, we asked AI, can I filter clients with GA data? GA is Google Analytics data. And we found out a lot of them are actually without this data. We can do the analysis without it, so no worries about that part. But as you can see, we don't have full data sets here on your local repository with your Hugging Face dataset. And you need to know and keep this in mind every single time. Make sure what data you have and the quality of it and what you can do with it. One technical detail, some availability flags are nil, not false. So inside of our data set, we will most likely expect true or false, but we have some other values there as well. We have nil values. So filter it with is true and never with equals false, for example. And we have a question number 3. How many daily rows actually have impressions? And as you can see, some stuff, same stuff here. We have some missing data and we have some gaps. Sometimes in Boolean columns, as I mentioned, we have nil values, and you need to know how to handle that part. You will do some normalizations and cleanups all the time while you are doing ML. So you need to be aware of that, and that could highly affect the analysis and outputs and outcomes of your ML model. And this is the way how to use AI in the best case possible. Okay, so this is the breakdown. Ask the data and then check the answers. What is one row? It is one page. Which dates? Who is missing? Do we have nils? And after that, check the answers. So take your finding to a different model or a fresh conversation and ask it to find what is wrong. You have to do it every single time and you must repeat it all the time. Because if you do a perfect analysis with the perfect model choice, you won't have anything significant if your data is not good. So we need a significant count of data and we need validated clean data as well. So by the way, we did so many cleanups right there and you are already able to do analysis, but we left some gaps there as well. And your goal is to avoid them. And this part is about your capstone. We already mentioned that we have these predefined lanes and we have this freestyle lane. So it is up to you. Nothing needs approval and you can switch lanes at any time. And here is one thing. We are actually already doing this part. So we already asked the question and we have a task and we are going step by step. So every weekly notebook is one piece of it. And the finish is deployed research paper, a public web page with your name on it. Weeks 7 and 8, teach it and ship it. So nobody needs web skills today. Okay. I mentioned these two questions in the very beginning, and what we are solving is the most critical one. And I want to tell you the story behind that question. We are not just trying to get the traffic to a particular page. We are trying to figure out the way how to make money for somebody or for ourselves. Behind the SEO story, all of these website owners have one goal. Most of them want to sell a product or a service. And they have two main strategies. They can spend the money on ads or they can do SEO. So with SEO, their goal is clearly to get this traffic. And in order to do that, we need to have something valuable for our readers. So this is the way how we are creating value for their readers. So you need to know what to fix in order to provide the value to the website readers. Their final goal, in most cases, is to earn money from the content. And from there come the strategy questions: what to publish, what specs, when to optimize, how to monitor. So we have so many decisions to make behind this process, and our analysis supports them. One more thing, and this is very, very important: the capstone research paper. We will do this capstone full analysis with the ML model, and I will guide you how to create the research paper as well. And this research paper will be very important for all of you. So you can do it, you can use it in so many places. But you need to figure out what is your goal, and you need to define who you are pitching. You need to know what you want to achieve with this internship, with this ML program, and with this research paper. So are we looking for a new interviews maybe, or are we looking for some social media content to engage our audience? So every audience needs a different direction of writing. So we will frame this when in our next weeks, but keep it in mind. We will do some deeper analysis there later. So week 7 teaches it fully. So no worries about this part at all. But it will be very, very interesting, and probably the first thing like this that you ever did. And yeah, we mentioned this 100 times already, but these two things you need to know exactly all the time. About the submission, we have this folder and an empty txt file. So put there your deployment URL once you are done. We are not yet there, but just keep in mind. And inside of this file, you will have option to put to publish paper independently or inside of your currently used portfolio. Totally fine. And about assignments, you will always submit only the same repository URL that you are using from the very beginning, and that's it. So one more rule: no claims. I proved Google's algorithm, I broke Google's algorithm. We need to keep these things serious, and we will be there very, very soon. Okay, I mentioned this so many times in this presentation, this MD file. You already have it in your repository. I'm not so sure, are you aware of it? And here's the full name of it. So here's the part that I mentioned in the first slides. This could be a golden nugget of everything inside of your whole repository. This MD file contains all the questions that you will ever need inside of this ML field. So we have 21 sections and 142 core questions, from framing to data, models, to validation, deployment, ethics, everything. So my perspective on this: use it at the start with AI for every single analysis. So everything we did today came from section 3, and you can check it out inside of this MD file. And sections 19 is a complete first principles checklist. So you can run it on any ML model, ML problem you ever start. So you can use any other data set as well. That's totally fine. So I want to challenge you and use this MD file with your agent and try to explore your current GitHub repository and your data set with it. Make sure to read it fully. You have so many valuable insights there, and the language is very, very clean. I promise that. And this is the trick I promised at the beginning, the one that solves 90% of your doubts. So let me know in the comment section, what do you think about it? Have you tried it, and what results you get? And we are wrapping up next week. We have our data engineer mentor, Haris Hodzic. He is a backend developer, and he is mentor on backend internship track. He will explain all the data sets and all the background story about our data. A Google Search Console, analytics, landing in BigQuery, daily sync, and many, many other things. So we will talk exactly about the stuff he already did for FlyRank. And he will show you the chat I keep teasing how model can cheat by picking the answer and how perfect score falls apart. So it will be 100% very, very interesting. I promise that. Okay, we had two numbers and I want them to stick in your head. Really, 24 and 74 are these two numbers. So we had the rule and we had the model, and the whole difference came from framing the question right. Keep that in mind. So important thing to do. 24 to 74 is what a well-framed question looks like, and that is the whole goal of this game. If you have any questions, let me know in the comment section. Let me know in my LinkedIn inbox. You have my LinkedIn description in the LinkedIn profile inside the description of this video, and you can check it. You can actually comment on our assignments inside the portal, and pretty much that's it. We are good to go today. Thank you very much, and see you next week.